In these next problems, we're working on finding the asymptotes of rational functions. Finding vertical asymptotes is pretty easy. You're just looking where the denominator is equal to 0 and solving for that. So if I had a simple function like x plus 1 over x minus 1, the place where the denominator is 0 would be where x equals 1, and there would be a vertical asymptote there. In the problems we're looking at today, we're going to be using the rules for horizontal asymptotes. And there's three things that can be happening here. The first situation is when the denominator has a higher degree than the numerator. So let's say we had x plus 1 over x squared minus 2. Here, the denominator has a higher degree. If that's the case, your horizontal asymptote is going to be the line y equals 0 every time. Now, if the numerator and the denominator have the same degree, it's a little bit more complicated. So let's say we had 2x plus 1 over 3x minus 5 as our function. What you do is you take the leading coefficient of, so that the top term, the highest term, you take the coefficient of the numerator and the denominator, and that is the line. So it's, in this case, I have 2 over 3. Our line would be y equals 2/3. So A and B give you horizontal asymptotes, either y equals 0 or y equals, if the degrees are the same, the coefficients of the leading terms over each other. Now the other situation you can have does not give you a horizontal asymptote, it gives you a slant asymptote, and that is if the numerator has a higher degree. And if that's the case, let's say you had x cubed plus 1 over x squared minus 2. To figure out the asymptote, you actually have to divide. So you would take x cubed, and I'm going to write this out as 0x squared plus 0x plus 1, and divide it by x squared plus 0x minus 2. And you would do the division, and what you get for an answer up here is going to be your line, your equation for your line of the slant asymptote. All right, let's look at a couple of problems. This first one says, find the horizontal asymptote of this graph, 8 over x minus 3. Now this is a situation where the degree of the term in the denominator is bigger. We have x here, we just have a constant here. Whenever the bottom is bigger, the line is y equals 0. That's all there is to that. Let's take a look at this next one. It says, write the equation for the horizontal asymptote of the graph of the function if it exists. So we have 4x to the 5th plus x plus 1 over 4x to the 5th plus 4x minus 5. The degree of the leading term here is the same on the top and the bottom. What that means is that we take the coefficients and put them over each other, so we get 4 over 4, or the line is y equals 1. And here we have a function, 2x cubed minus 3 over 5x squared minus 4. This is a situation where the degree of the numerator is larger. And in this case, you have to do the division, and what you get is not a horizontal asymptote, but a slant asymptote. But let's read the question here. It says, write the equation for the horizontal asymptote of the graph of the function if it exists. Well, it doesn't. There's no horizontal asymptote here. It's slant, so it does not exist. And that's really all the work you'd have to do for this one. If you wanted to do the division, you could do that. You could set it up like regular polynomial division. So 2x cubed plus 0x squared plus 0x minus 3, and we'll divide by 5x squared plus 0x minus 4. And I won't do this whole thing, but first we'd want to see what term do you need to turn this x squared into 2x cubed. So I would multiply, so it's 5x squared, and I want to turn it into 2x cubed. I would multiply by 2/5 x. So 2/5 x times 5x squared is going to give you 2x cubed. And I won't finish the rest of it. I think you get a little bit of change out here, but your line is basically y equals 2/5 x, and that is a slant line, and that's your slant asymptote. But in this case, we didn't even have to do that work. So that's some problems with finding horizontal asymptotes to rational functions. My name is Larry. I'm a teacher at EdVisions Off Campus. It's an online project-based school in Minnesota. If you're interested, you can find us on the web at lovethisSchool.org. Thanks.